Hi, I am Madhu. I am studying computer science engineering in SRIT. Today I am going to tell about gas chromatography. Contents: Gas chromatography introduction, its types, principles, GC mainly composite steps, workings and applications. Gas chromatography introduction. It is a process of separating components from a given crude break by using a gaseous mobile phase. It involves a sample being vaporized and injected onto the head of the chromatography column. The sample is transported by the column by the flow of inert gaseous mobile phase. The column itself contains a liquid stationary phase which adsorbed on the surface of an inert solid. It is two types: gas-solid chromatography. Here, the mobile phase is a gas while the stationary phase is a solid, used for separation of low molecular gases. Example: air components H2 and S, CS2, CO2, rare gases CO and oxides of nitrogen. Gas-liquid chromatography. The mobile phase is gas while the stationary phase is liquid, retained on the surface as inert solid by adsorption of chemical bonding. Principle. The principle of separation in GC is partition. The mixture of components to be separated is converted to a vapor and mixed with the gaseous phase. The component which is more soluble in stationary phase travels slower and eluted later. The component which is less soluble in the stationary phase travels faster and eluted out first. No two components have same partition coefficient conditions. Partition coefficient condition is the ratio of solubility of substance distributed between two immiscible liquids at a constant temperature. GC mainly composed following steps: carrier gas in cylinder. Helium, N2, H, argon are used as carrier gases. Helium is preferred for thermal conductivity detectors because its high thermal conductivity relative to that of organic vapors. Float rate is adjusted by means of a needle valve mounted on the base of the flow matter and controlled by the capillary restrictions. The operating efficiency of the gas chromatography is directly dependent on the maintenance of the constant gas flow. Sample injection system. Liquid samples are injected by a micro syringe with a needle inserted through a self-scaling. Gaseous samples are injected by a gas-tight syringe or through a bypass loop and valves. Typical sample volumes range from 0.1 to 0.2 ml. The separation column. The heart of GC is the column which is made of metals bent in U-shape or coiled into open spiral a flat pancake shape. Several sizes of columns are used depending upon the requirements. Liquid phases. An infinity variety of liquid phases are available limited only by their volatility, thermal stability and ability to wet the support. No signal phase will serve for all separation problems at all temperature supports. The structure and surface characteristics of materials are important parameters which determine efficiency and degree of separation. The separation area be large to ensure the rapid attainment of equilibrium between stationary and mobile phases. Gas glass beads with low surface area and low porosity can be used up to three stationary phases. Detectors. Detectors sense the arrival of separated components and provide a signal. These are either concentration dependent or mass dependent. The detector should be close to the column exit and the correct temperature to prevent. Recorder. The recorder should be generally 10 MV fitted with a fast response time. The recorder should be connected with a series of good quality resistors connected across the input to attenuate the large signals. Working gas chromatography separately and analyzes compound in a sample based on their interactions with a stationary phase and moving gas phase. The sample is injected into a heated injector, vaporizing it. The vaporized compounds travel through a column where they interact with the stationary phase. Compound with different affinities for the stationary phase elute at different times creating distinct peaks. The detector measures these peaks, producing a chromatography that helps identify and quantity the components in the sample. Applications: it is used in a chemical analysis in laboratories, it is used in environmental monitoring, it is used in forensic science, it is used in food and flavor analysis, it is used in petrochemical industry, it is used in pharmaceutical industry. Thank you.